In our opening assignment, we were asked about linear equations, just to get a little background on what you already know. We're going to be solving them, but like I said, what exactly is a linear equation? Well, a linear equation, as some of you mentioned, form a line on the coordinate plane. There's more to it than that, but that's part of it. It is an equation where the variable is to the first degree. That makes it linear. X plus 5 equals 9 is a linear equation. 2x minus 1 is a two-step equals 11 is a two-step linear equation. The exponent is to the first degree. If I were to write an equation like x squared minus 1 equals 48, that would be a quadratic equation. In the linear, we said we're going to go and form lines on the coordinate plane. So we may have a line that is uphill positive or downhill negative. But when we look at quadratics, they're going to form those U-shaped parabolas. All right, so that's just a little bit of background. But let's look at a textbook definition. In a linear equation, the variable is raised to the first power, and it does not occur in the denominator, or inside a square root symbol, or inside absolute value symbols. So there's a little bit more to it than we thought. The graph of that linear equation is a straight line. It could be the horizontal zero slope. It could be the vertical line undefined slope. It could be going uphill positive or downhill negative. And we'll spend a lot of time talking about and graphing them. To solve a linear equation, you will use inverse operations, and our goal is to isolate the variable. You're going to start by writing the original equation. When I see a subtraction equation, I'm going to add. So I'm doing the inverse. The inverse of subtraction is addition. I'll add 5 to both sides, and I'll get x is equal to negative 8. I never want to draw the conclusion that negative 8 is the solution unless I go ahead and do some checking. So I'm going to replace negative 8 into my original equation. I'll start by writing x minus 5 equals negative 8. I'm now going to replace x with negative 8. Negative 8 minus 5, does that equal negative 13? Well, let's see. Subtraction tells us to add the opposite. We just spent a lot of time on that topic. And we see that when we have the same signs, we go ahead and add, and we see the two sides check. We were successful. All right, so now I mentioned briefly something about these properties of equality. In a property of equality, such as the addition property of equality, it says that if I add a number to the left and I add the same number to the right, it will keep its equality. It will still be equivalent. So I'm going to try to undo. And by undoing this, I'm going to use the inverse operation. Once again, I'm going to add. I'm going to add 3 to both sides. So this is my transformations. It's telling me what exactly that I'm doing. I generally write the original equation. It then tells me what to do, and we're adding. And then we get that x is equal to 8. That is my solution. So when we find the value of the variable, we call that the solution. Let's look at the subtraction property of equality. It states that we can subtract the same number on both sides and still keep the true identity of the expression on either side. I see addition, inverse operation is subtraction, so this is the subtraction property of equality. I will subtract 6 on both sides, and I get a solution of x is equal to 4. If I were again to substitute in that 4, I would have 4 plus 6, and that equals 10, and it checks. Sometimes you're going to see me give you an equation where when you solve it, your variable's on the right. You want to do something called interchange and just put your variable first. Just a little something that, again, sets you to put your solution in the correct order. So remember, something key here. Any number plus its additive inverse or its opposite equals 0, and that's helping us in these one steps to isolate the variable if we see an addition or subtraction equation. So let's go ahead and add 7 to both sides. We know that we have to watch our signs, and we're going to see that we have 1. Well, I don't know if that's right. Maybe I made a sign error. Maybe I made a calculation error. I'm going to replace that in. I'm going to do the math, which means add the opposite, and I see that it works. Especially when we have unlike signs, it's always good to do a check. Here's one of those examples where my variable is on the right. I have 4, so I'm going to do the inverse. I will subtract 4, which is our subtraction property of equality. I have, again, negative 12 minus 4, which tells me to keep and add the opposite, which gives me a negative 16. I'll interchange and write my x is equal to negative 16, and I am going to do the check. I have negative 12 is equal to 4 plus a negative 16. Well, my signs are unlike. I'll subtract, and I get negative 12, so it does check. Again, we always want to be sure that we do have the right solution. So I was talking about these transformations. It says first simplify in this one. So you start by writing your original equation. Negative 8 is equal to n minus a negative 4. Now there are 2 ways to approach this. You could add a negative 4 to both sides, or you could, as the book suggests, simplify. And what will I do to simplify? I'm just going to add the opposite. I now can go ahead and subtract 4 on both sides. And then I'll simplify again. And then I'll interchange. So in this particular problem, I'm doing a 2-column solving. And on the right, I'm telling you exactly what I'm doing in each step. That sort of justifies what I'm doing. Try these 4 on your own, and we'll see how you did. Be careful with your signs. Again, I see a negative 3. I'm going to add 3 to both sides. I get x is equal to 14. On the second one, I could simplify first by adding the opposite. I'll then go ahead and subtract. And I get x is equal to 0. 0 minus a negative 4, add the opposite, gives me 4, it works. In this one again, I see these parentheses and I see this negative sign, just like in the previous problem. I can go ahead and simplify. I now can subtract, use my subtraction property of equality, and I get x is equal to 12. Absolute value of negative 4 is 4. Remember, we simplify any expressions before we do any inverse operations. We'll go ahead and subtract 4 next, and I get x is equal to a negative 14. We haven't really done much in the way of translations since we did some expressions back in chapter 1. So let's take a look at some translations once again. Now we're going to add this to the mix. We're going to see the word is or equals to, and is represents that equal to sign. We'll see equivalent to, is equal to, totals, whatever those words are that tells me that we're now looking at sentences instead of expressions. 2 times a number increased by 1 is 7. If you said 2n plus 1 equals 7, you were right. Let's look at one more translation because these will come in handy when we're solving some word problems. The product of a number and 4, the product of a number and 4 less 2 is 14. And again, you see how that works. The last part of this lesson for today is I want you to take a look at these three statements, and I want you to write an equation and solve it for each. Write the equation and solve. These we will go over in class.